If you're looking for a deep dive explanation of delegates, go beyond the basics and to learn through practical applications, then you have come to the right place. Hey everyone, Troll here and welcome to the Decode Bytes channel. Today we are going to move beyond the basics of delegates and explore their real-world applications in design patterns like observer design pattern, strategy design pattern, and event-based asynchronous pattern, as well as functional programming. Buckle up, it is gonna be a coding adventure. As always, before diving into details, let's see what we are going to learn. We are going to talk about delegates compilation. We'll understand how .NET Platform compiles delegates behind the scenes. And of course, as a senior developer, where do we use delegates in our practice? So, real-world examples of delegates contain event-driven programming, event-based asynchronous pattern, observer design pattern using delegates, strategy design pattern using delegates, the LINQ with delegates, and of course concurrency like multi-threading parallel asynchronous programming with delegates. And at the end, I will show you the functional programming that will be implemented with delegates. So it is going to be really interesting. Let's get started. Well, let's try to understand how .NET Platform generates delegates and how actual .NET Platform understands delegates behind the scenes. For that reason, I created a simple solution here, and for this solution, we have multiple projects, which I'm going to explain throughout the tutorial. And if you want to follow me, just go to the github.com, Troll Suleimani, and here we have per topic, we have a branch. Per video tutorial, we have a branch. For example, for the current tutorial, we have practical delegates. Just use tutorial/practical delegates, okay? Cool. Let's try to create a simple delegate and to understand how .NET Platform generates delegates, compiles delegates behind the scenes. Okay, I'm just going to use for now a func delegate. Decimal. By the way, if you want to understand the delegates and if you want to actually master C# delegates like a senior, just check my another tutorial called Master C# Delegates like a Senior, and you will understand all the concepts related to delegates plus action, func, and custom delegates creation. Cool. Now let's create a multiple delegate here, and for the given delegate, I'm going to use d multiplied by 5. Yeah. That's really simple. Delegate, and let's call and check if everything is working or not. And I'm just going to use console.writeLine. Okay, Control key D. Let's format it. Cool. Now let's run our application. And everything is working as expected. 30. Cool. What I'm actually going to do, I'm just going to open File Explorer. From the File Explorer, bin, debug.net, and I'm going to use JetBrains.py. This is really cool application that will help you to understand details, compiler-generated details. Okay, let me just move our DLL file called behind the scenes of delegates, and let's open our program, open our main method, and this is our main method code. But from the low-level C# perspective, as you can see, we have low-level C#. Now we have a little bit complicated mechanism. Let's see, we have compiler generated private sealed class. You see, this is private sealed class, and for the private sealed class, we have internal decimal method that accepts this decimal and calls decimal multiple. So we have a wrapper over our delegate. This is actually a syntactic sugar. Let's say the delegates are actually syntactical sugar in this case, because when you write your delegate, C# behind the scenes generates a special class and wraps the functionality to this class. Cool. And let's remove this one and try to create another delegate and to try to understand if we will get another class for it. But let's see. I'm just using the same func delegate, and let's make it 2 and multiply by 7. It doesn't matter. I'm just going to call it with 6. And that's actually all. Let's run it. Everything is working. Let's again go to our .NET 8 folder. Let's open JetBrains.py, move our DLL, and let's open and see. Actually, .NET will not generate a second class, but will use the same class, but with additional method here. So you see, we have 2 methods, and per delegate we have a method, but for the delegates we have one single class. That's how actually .NET Platform understands delegates. Event-driven programming. Event-driven programming is actually a programming paradigm. In .NET Platform, we are actively using different type of programming paradigm, and this helps us to build different type of applications. Depending from our requirement, we are able to use different type of paradigms in our C# language. So event-driven programming is actually one of them, where the flow of program execution is determined by events. We are actively using events. They are special type of methods, let's say, and the program flow relies on events rather than a predetermined sequence of instructions. In our event-driven programming, in short EDP, we have different type of key elements. So let's see, we have events. Events are occurrences within the system that signals something significant has happened. So something happened, we are getting some type of signal from the system that something that happened, and this is called event. We have event handlers. Actually, event handlers are methods that respond to the specific event. So you have a signal, you're responding to the signals. It means you have event, you're responding to it using event handlers. We have publishers. Publishers are actually, the synonym for them is event sources. Publishers are special type of objects that generate events. So for the event, for the signal, we need to have a source for this signal. Actually, publisher is a source for our signal, for our events. And we have, of course, subscriber. For the subscriber, we have synonym called event listener. Subscribers are also objects that register interests in event and have event handlers to respond to them. Okay, so we have producer, we are sending signal using events, they are events, and we have method that respond to specific event called event handlers. And from the subscriber's perspective, we are registering to these events and we are having event handlers to respond to them. And of course, delegates. So delegates are types that define the signature of event handlers. So for the event-driven programming, the core element actually is our delegate. Okay, let's switch to our project. In our project, we have event-driven programming folder. Under that, we have a special application that we developed before. And if you want to understand how to develop this type of application, we are using reflection interfaces. We are decoupling our system. Just check my master C# interfaces like a senior tutorial to learn more. But for now, I will focus only event-driven programming side of this application. We have Windows Form application. Now, Windows Form here, we have a reload button. Okay, let me click on that. It doesn't matter which type of component you are getting in your form, just double clicking or other type of behaviors possible for you to be used. So you can, for example, for the button, right click, properties, and here we have events. So as you can see, we have tons of events here, and button click is one of them. So when you click to the button, you will get special type of method, okay, template method, and you can fill the information here, and you can type anything you want depending from your requirement. But what actually this method is? So in this method, we have one reference. Let's go for it. And voila, we have main form designer CS, and we have a click event handler. So this is a delegate. Let's go to our event handler. So you see, event handler is a delegate. Whenever you're using components from Windows Forms, you are doing operations like click, double click, mouse move, depending from your events, you're actively using delegates behind the scenes. So delegates is the core element of creating events in our scenario, in our event-driven programming. Okay. And it is possible for you not just click, but also manually type your event subscription process. So in my case, for Decode Bytes Windows Form, we have Form Provider Visualizer. And here we have, in our button, we have a click, and I am subscribing to this click event. Okay. And this is actually our delegate. This event behind the scenes uses delegates. That's how actually we are actively using delegates everywhere, in every component in Windows Forms, even in WPF. You can use in WPF, of course, MVVM and decouple the process, but actually it is possible for you for Windows Forms, for WPF, actively use event-based programming and use delegates in this scenario. So if you want to actually create better applications, you need to understand how delegates work. Let's talk about event-based asynchronous pattern. This pattern was introduced in .NET version 2 after asynchronous programming model that was introduced in .NET version 1. Event-based asynchronous pattern employs events to signal the completion of asynchronous operations, keeping the main thread responsive and avoid blocking. It is a pattern for designing asynchronous operations that uses events to notify the client when an operation is completed. So there is some type of event, and we are using this event to get response to know what happened at the end from the operation side. So let's try to understand the steps for event-based asynchronous patterns. First, client calls a method to initiate the asynchronous operation. There is some type of method. We are calling this method to run asynchronously. But method directly returns response, not blocking the caller. So we are returning immediately to not block our main thread. Operation execute on a separate thread or thread pool. Operation raises an event when finishes. It is possible to get success, failure, or cancellation. And client handles events to retrieve results or handle errors. Okay, let me show you a real-world example of using event-based asynchronous pattern. Actually, I have created two applications for you, one for Windows Form, other one for the console application. The purpose here is to show you that there is no dependency between Windows Form and event-based asynchronous pattern. This is actually possible for you to apply this pattern for any type of applications. If you want, you can apply it for Windows Forms, WPF, console, etc. So for the Windows Form, I have a really simple application here. For the application, I have three main components: the button, progress bar, and background worker. When I click this button, it will call background workers functionality. This functionality will run asynchronously using thread pool, and we have special event to subscribe to this functionality to get response. So when I click the download button, as you can see, there is no blocker from the thread side, from the background worker side. So it is possible for me to track the progress of the operation using progress bar, and I'm getting the exact response. So what happens behind the scenes, I'm just actually downloading some XML file from the internet. But when I click to the button, I am calling background workers run worker asynchronously. From the postfix, you already understand that this is asynchronous operation, but this is a little bit different rather than our async await type of operations. This is a little bit old design pattern to implement asynchronous pattern. Actually, the first one was asynchronous programming model, then event-based asynchronous pattern, and the last one is our async await type pattern that is recommended version of implementing asynchronous programming. For the background worker, we have beside than running worker asynchronously, we have two main operations here. One is do work, the actual operation that we want to do, and the other one is run worker completed, where we want to handle the operation result. Okay, for the do work, let's see, we are just calling new XML documents load method, and we are loading some XML from the internet. And for the background workers run worker completed, we have again the event mechanism that we are handling our errors and success of the operation. This is how actually we are doing marshalling from the background operation to the main thread. And we are not blocking our main thread, and now our main thread is responsive. It continues working without any break, but it is possible for us to run any operation in background without without stopping our application actually. The other application is our console application. In this application, I have also used an event-based asynchronous pattern, but with old web client class. For the web client, we have download file asynchronously. This is the same pattern. We have a void returning, and we have some arguments to run this operation. I am just calling download file asynchronously with two arguments. The first one is exactly where I want to download this information, and the second one is where I want to download this information, where I want to save this information. And I have download file completed event. This is actually a delegate type of mechanism. So let's see, async completed event handler is a delegate. So we have object sender and async completed event arc. So you see that our event-based asynchronous programming is actively using delegates behind the scenes, and the same process is also applicable for the web clients download file and download file completed. You have some operation, and you are exactly subscribing to this operation. Okay, you are subscribing to this operation to get the final response, if it is failed or if it is success, and you can do any additional operation for this process actually when you subscribe to this event. That's how actually we are implementing event-based asynchronous pattern with delegates. Time to talk about observer design pattern using delegates. Actually, this tutorial is not going to cover observer design pattern itself. I will provide some information, but observer design pattern is a huge topic. It requires at least 2 or 3 this type of tutorial to record, to learn and master observer design pattern. But the purpose here is to show you that it is possible for you to implement observer design pattern using delegates in case you are using delegates and events actually. What actual observer design pattern is? Observer design pattern establishes a one-to-many dependency between objects. So we have a subject, we have observers. It is possible for us to notify these observers using one subject, and we have loosely coupling dependency between this subject and observers. It is possible for us to work on subject without affecting observers, and it is the same is applicable for observer. Okay. Observer design pattern allows one object, the subject, to notify multiple other objects about the state changes, and this pattern promotes loosely coupling between objects. This is our simple implementation of observer design pattern. We have iPublisher, iSubscriber interfaces. Our author implements iPublisher. Our user implements iSubscriber. We want to have interaction between author and user, but we are not directly communicating with author and user. Instead, we are using interfaces to interact with each other, and it will help us to easily change author and user without affecting each other. Let me show you how in practice we are implementing it. So we have observer design pattern folder here, and we have custom events in practice.delegates. Actually, if you want to understand more, if you want to dive into details of observer design patterns implementations in C#, just check my C# events like a senior tutorial where I explain it and where I developed this application from scratch. But for now, let's focus on our delegates. This is our author that actually implements iPublisher. Let's go to our interface, and we have 3 functionalities as we described in our presentation. For the user, we also have a subscriber interface where we are subscribing, unsubscribing, and we are getting update. But for the author, we did a little bit changes here, and we have a direct dependency from not a subscriber, but from the subscriber delegate. In this case, we have a list of delegates. So you see we have dictionary, good, subscribe, delegate, and we are providing not iSubscriber but this delegate. It means any method with that matches to this delegate will be a subscriber. Let me show you. Here we have program CS, and program CS we have author. It is our publisher, okay? It is our publisher, and we have user. User is our subscriber. So our author adds a subscriber, but not user. We are adding the update method as a subscriber. Okay, so we are adding this delegate as a subscriber. It means when we run this application and when we publish, we will get published information for these two update methods. And for the second one, we are changing article and we are removing our subscriber. It is possible for us to remove this delegate using different techniques. I have used only ID mechanism here. For that reason, I am accepting here ID and delegate itself to identify the delegate. Okay, and I'm just removing subscriber. It means I am removing the second user ID and it will remove this update. So I will see this published information twice and then only first one time because I have removed the second user. Let's run it and see. By the way, if you're implementing observer design pattern using your custom events, using the recommended events, it doesn't matter. You are using delegates for your implementation. Actually, this is our article information. 1, 2 information here and only 1 information here because we changed our article and then we removed our second subscriber here. As I mentioned before, we have events implementation, observer design pattern implementation for events and for custom events, and plus Microsoft based events. They both use delegate when they implement observer design pattern. How about strategy design patterns? Strategy design pattern is one of the important design patterns that we are using in our daily basis. And of course, it doesn't matter if you're junior or senior developer. I know that you are actively using strategy pattern. Sometimes you don't know it is strategy, but you are actively using it. And also, most of the design patterns rely on strategy design pattern behind the scenes in a philosophical manner. Okay, it is possible for us to implement strategy design pattern with different techniques, especially with interfaces and delegates. Right now, I will show you implementing strategy design pattern using delegates. Of course, it is not possible for us to cover all the cases related to strategy pattern in just 5 minutes. I will just directly dive into details of strategy implementation in C# using delegates. But first, let's try to understand what strategy design pattern is. Strategy design pattern encapsulates a family of algorithms, making them interchangeable. It allows clients to select and replace algorithms at runtime without modifying the context object and promotes flexibility, maintainability, and testability. Let me show you a simple example of implementing strategy design pattern in C#. We have strategy with delegate. Here we have employee service. Okay, this employee service has one functionality called get employees, but it accepts a delegate as a predicate. If you want to learn more about delegates, we have a special tutorial called Master C# Delegates like a Senior, and you will understand why we are using delegates in our practice. But for now, let's focus on our topic. We have a list of information. You may get this information from the repository. In most cases, you're doing it like that. So let's say we are repository. We are getting this information from a repository, and we have, of course, in LINQ we have different mechanism, but let's say we have list of information and we using predicate, we are getting information. So we are not getting all the information, but depending from our algorithm here provided by the delegate, we are filtering out our information and we are returning only the relevant information. Okay, let's go to the program CS. We are calling our employee service, just instantiating employee service, get employee, and I am providing the exact algorithm. This is our let's go to our presentation. It says that we are not modifying our context object. Yes, this is our context object. So I am just providing the piece of algorithm from outside without changing my context. So I have main algorithm here and I have changeable algorithm, and I'm providing this algorithm for user to provide it from the outside. So user is able to change this algorithm, but it will not affect our main structure. Okay, it will of course affect to our result, but from the code perspective it will not affect to our context, to our main source base algorithm here. So it is, let's run this. So we are getting employees only with salary greater than 4,000. Let's check it. And then I will change this algorithm to see if it is possible for us to provide other type of algorithms. So we have only 2 employees here. Let's change it to 2,000, run it, and that's all. We have now 3 employees. So that's how we are implementing strategy logic, strategy pattern. This is, of course, the really simple explanation of strategy, but the purpose here is to show you that when you provide some type of algorithm from outside, it is going to be your strategical logic. Okay, so you're providing some type of algorithm from outside to make your application to work properly in this case. This is going to be one of the easiest subtopics for the current tutorial, because I know that you have already used LINQ, especially method-based syntax. We have query-based syntax and method-based syntax when we are interacting with LINQ, and for the method-based syntax, we are actively using delegates. Let's try to remember what actually LINQ is. LINQ is a unified way of interacting with different data sources. So you have different type of data sources like in-memory collection, SQL, JSON, XML, etc. And you want to have one single unified contract interface to work with this type of data sources, because at the end they are actually data sources. So you need to have one single way of interacting with this type of data sources, and actually LINQ helps us to build this type of infrastructure. Okay. For the LINQ, we have link to objects, link to entities, link to XML, link to dataset. I don't know, the link to custom provider like link to JSON, link to Amazon, link to INI. You can even implement your own LINQ if you know about the expression trees, delegates, and etc. Okay, let me show you one simple example here. This is our project, and in this project we have just simple list. Okay, and for the list I'm just going to call some sort of extension methods from the LINQ. One of them is actually our where. So the where is using the func delegate here. Okay, so let's select another one. This is our select. It is also using func delegate. Let's go for any. The overload version of this method is also working with func. Let's select the first or default. This is also working with func delegate. So you see our method-based syntax especially is actively using delegates. This is how we are applying delegates when we are working with LINQ. Concurrency is doing more than one work at a given time. Actually do one thing while the system is working on another thing. This is how we are defining concurrency. If you want to dive into details of concurrency with async await, just check my another tutorial, Master C# async await with concurrency like a senior. For now, I will focus only for the delegates related to concurrence. Okay, the concurrent, we have different set of types for the concurrency. We have multi-threading, asynchronous programming, reactive programming, and also parallel processing is a part of multi-threading. Okay, I have explained all this stuff in my mentioned tutorial. Let's switch to our project and try to use this multi-threading, parallel, and asynchronous functionalities from the C#. For the multi-threading, we can use the old school thread that's not recommended, and also thread pool that helps us to build task parallel libraries, async await functionality, and all the new stuff behind the scenes actively using thread pool. For the thread, let's just for an example, I will show you how thread is working. For the thread, we have parameterized thread start and thread start class delegates. They are actual delegates. Let me show you parameterized thread start. This is our delegate. So if you want to run a thread in your legacy code, you will use a thread with delegate. Okay, for the thread pool, let's go for it. Thread pool. In our thread pool, we have queuser work item that actually accepts wait callback, and there should be another action type of delegate. Yeah, and this one, wait callback, is actually a delegate. So let me show you wait callback, and voila, this is a delegate. So the multi-threading is actively using delegates. Okay, let's switch to the parallel programming. For the parallel programming is also a part of multi-threading, and behind the scenes it uses thread pool. So we have for each, we're actively using for each to parallelize the process, and everywhere we have delegates. This is our action delegate. Let me show you the for each stuff. Also, we have a generic version for that, just using for each here. And for the for each, we also have delegate here. Okay. And how about asynchronous programming? For the asynchronous programming, I will show you the task parallel library here. So for example, for the task, we have task run. It actually works with delegate. We have task factory start new. This also works with delegate. So as you may notice, for the concurrency, it doesn't matter if you're working with CPU based applications or input output bound applications, everywhere we are using delegates. The last subtopic in our tutorial is going to be functional programming with delegates. Of course, functional programming is a huge topic. It is not possible to cover it in one tutorial. If you want me to create videos related to functional programming, just type below in the comments and I will create really interesting videos for you related to functional programming. Before diving into details, let's try to understand what is functional programming. Functional programming is a declarative programming paradigm. So in .NET, in C#, we are applying different programming paradigms, and one of them is a functional programming. For the C# we are using object-oriented programming with imperative manner, but functional programming is a declarative programming paradigm. Functional programming relies on function composition. If you are actively using LINQ and Lambda, it means you are already using functional programming in C#. In functional programming, every function is a first-level citizens, and they are deterministic math functions. And when you apply functional programming, it means you are creating declarative code through small functions. Let's go to our project. In our project, we have programming project in our solution, and I have created two extension methods for you. Actually, in most cases, we are applying functional programming using method extensions, and here we have special guests called delegates. If you have worked with LINQ, if you have checked the LINQ syntax behind the scenes, you may compare it with LINQ. We have a completely same type of implementation structure like in LINQ. These are actually functional programming elements. These are actually functions, but you may say that in C# we have classes, and inside classes we have methods, and we are just creating a method here, but this is not actually a method. Okay, let me show you why this is not actually a method but a functional programming element. In functional programming, for example, if you are defining some arguments, you should only interact with this argument. There is no hidden state, there is no hidden elements to interact with. So in my case, I have source, I have predicate, and I am working with source and predicate that's defined from the signature. So in signature, everything is clear. You already know that you will interact with only method arguments here. Okay, and we have enumerable T. There is no hidden exception throwing, there is no hidden response returning. We are returning only enumerable, and when I hide the implementation from the signature, it is possible for you to directly read and understand that this method will return enumerable T and will work only with predicate and source. That's obvious, and that's how we are creating functional programming elements called functions. Okay, this is one of the signs of using functional programming. So let me show you the usage here. We have program CS. I have created numbers as an enumerable integer, and we are applying filter and map like we are applying LINQ methods. And let's run it, and voila, everything is working. Is that all? Well, not quite. It is possible to use delegates in a variety of other scenarios, but that's all for me for now. If you like the video, don't forget to subscribe if you haven't already. Hit the like button, and I'll see you in the next tutorial.